Species diversity is the variety and abundance of different types of organisms which inhabit an area. Species diversity consists of species richness and species evenness in the area. Experiments can be tested on species diversity, which can manipulate species diversity to show that increasing the number of species or the evenness of species abundances enhances the mean levels of ecosystem function. It may also be enhanced by adding complementary species into the ecosystem. There are different types of diversities: alpha, beta, and gamma. Alpha diversity is the diversity of individual sample units. Beta diversity is the amount of compositional variation in a sample or a collection of sample units. And lastly, gamma diversity is the overall diversity in a collection of sample units, often called landscape level diversity. There are also factors that might impact species diversity. Deforestation and nuclear wars are extreme measures that can affect species diversity. Some more common and less extreme factors may be urbanization, acid rain, invasive species, water diversion, fracking, or industrial agriculture. Species diversity is also one component of the concept biodiversity. Species richness is the number of species in a sample unit or other specified areas. Species richness is one component of the concept species diversity. It is an intuitive measure of diversity that includes inequality in relative abundance and a component of diversity. There are patterns of species richness that can be observed in multiple ways. There are different taxonomic groups of organisms that have more species than other groups, which shows richness by certain taxonomic groups. But there are other ways to view richness, such as geographic patterns. Latitudinal gradients are commonly shown in many taxonomic groups for species richness. There is usually higher species richness in the tropical regions than in most temperate or polar regions due to environment and climate. The two most species-rich habitats, however, are rainforests and coral reefs, which are of course located in tropical regions. Oddly enough, there are greater amounts of species richness in large islands and islands than there are closer to the mainland. There are similar patterns of this that are in habitat islands, which are forested mountaintops surrounded by arid land. Local species richness can be influenced by ecological factors. Higher productivity areas have higher species richness. There are also problems in species richness, though. New species arise through the process of speciation, and species are lost due to the process of extinction. For example, the 5 mass extinctions changed species richness to a greater extent in those times. Due to the inconsistent rate of extinction and speciation rates, species richness varies considerably through time. For a brief recap, species richness is the number of species in a sample unit or specified area. Species evenness is the distribution of species throughout an ecosystem in a given area. intuitive notion of diversity has the evenness or equability of abundance. A sample unit with more abundance is more diverse than a sample unit with abundant and sparse species. Communities and areas with less variation in relative abundance of species are usually considered to be more even than communities with more variation in relative abundance. In conclusion to this, communities with greater evenness are considered to have greater species diversity. To determine species diversity, there are several equations that can be used to help with the species diversity values. It is a data set that can be calculated by taking the weighted averages of species proportional abundances in the data set and taking the inverse of it. Different equations assign different weights to species richness and evenness. So depending on the circumstances, there are different most useful indexes to choose from. The equation that our class used were Simpson's diversity values and Shannon's diversity values. For the Shannon's value that comes out of the equation, the higher number, the higher the diversity. And there are two equations needed to complete the calculations. Pi equals Ni, capital N, is the first equation, and H equals negative sigma I equals 1 SPI ln pi, which is the second equation. Ni is the number of individuals of species I. Capital N is the total number of individuals of all species. Pi is relative abundance of species I. S is the total number of species, and H is the Shannon diversity index. For Simpson's diversity value, 0 represents infinite diversity, and 1 is no diversity. Therefore, for Simpson's diversity value, the bigger the value of D in the equation, the lower the diversity. Basically, the values are opposite of Shannon's values. To get over this problem, D is often subtracted from 1. The equation is D equals sigma little n parentheses little n minus 1 close parentheses over big N parentheses big N minus 1 close parentheses, where little n is the total number of organisms of a particular species, and big N is the total number of organisms of all species. Some events that are occurring due to species diversity is the evenness of species distribution in forestry. The Natural Path Urban Forestry Consultants, NPUFC, provides services inventorying street and park trees and developing management strategies for communities for the past 12 years. There is efforts to fix this because there are only a handful of species in the community. Dominant species from past planting is high maintenance, and many communities focus on brief lists that have not changed over decades, providing a monoculture population. There are species diversity problems with the species of lizards as a whole instead of individuals. There is an evenness problem in the lizard community. Not only are these two things an issue, there is an issue in the biodiversity in the ocean. There is a census of marine life in the global network of researchers and scientists trying to assess diversity, distribution, and abundance of life in oceans. Species diversity can cause many problems for the community in all variations of species around the globe.